Good morning, dear students. I am Dr. Srinivas Bhattani, Professor of Chemistry in St. Peter's Engineering College. So, in the last video, we have discussed the cracking. So, cracking are how many types? They are thermal cracking and catalytic cracking. Mainly two types of crackings we discussed. Thermal cracking is again divided into liquid phase thermal cracking and vapor phase thermal cracking. So depend upon the temperature. Okay, that also we have discussed. And in the catalytic cracking also two types. That is fixed bed type catalytic and moving bed type catalytic. So these are all we discussed in the last video. Okay, today we will discuss the synthetic petrol. What is the topic today? Synthetic petrol. Synthetic means artificial. So petrol mean is nothing but gasoline. We can say gasoline. Synthetic petrol. So petrol is mainly obtained from where? Petrol mainly obtained from the crude oil. The crude oil coming from where? Oil wells, especially in that is Saudi Arabian countries, Kuwait, Iraq, Iran. That area they are important. Major amount there. Here also in there in West Godavari and Krishna Basin especially. So that the crude oil comes from the oil wells. That is the process actually. But we can also obtain by synthetic process. Synthetic means the artificially. We can synthesize in the lab. By using. So they are again divided into three types mainly. Polymerization. One is the polymerization. First one is the polymerization, and the second one is the Fischer's-Tropsch process. Fischer's-Tropsch process, and third one also there, that is the Burgess process. Burgess. You can say Burgess or Burgess. So these types, using these three types, we can obtain the synthetic petrol or artificial petrol. So according to our syllabus, we have among these three we have only the Fischer's Tropsch process. We have that syllabus. So especially, whenever they asked in the examination, so write about the synthetic petrol using Fischer's-Tropsch process. So today we will going to discuss about the Fischer's-Tropsch process. Okay. So Fischer's-Tropsch process mean what? So this process, Fischer's-Tropsch process, is a collection of chemical reactions. What is that? It is a collection of chemical reactions that convert a mixture of carbon monoxide and hydrogen. Mixture of chemical reactions. Many chemical reactions that convert into carbon monoxide and hydrogen. What is that? In this process, the mixture of collection of mixture of chemicals. So especially convert from carbon monoxide and hydrogen. What is that? Carbon monoxide. So this process is a collection of chemical reactions, many reactions, convert a mixture of carbon monoxide and hydrogen into liquid hydrocarbons. What is that? The liquid hydrocarbons. Liquid hydrocarbons. So hydrocarbons mean from this we can get the. So this is the process collection. That is the precious process. So this process, a key component of gas to liquid technology. Liquid technology. Produce synthetic lubricant oil, synthetic fuels, synthetic lubricant along with petrol, synthetic fuel, synthetic lubricant oil, natural gas, biomass. When solid feedstock like coal is used, the solid feedstock is converted into gaseous reactants. So the mixture means we can say the feedstock. So we can take the coal, biomass, natural gas, whatever we have to take it. So all these feedstocks, coal, biomass, natural gas, or coke, whatever that, converted into the carbon monoxide and hydrogen, a mixture of carbon monoxide and hydrogens. So this will give the liquid hydrocarbons, mean crude oil. From crude oil we can convert the lubricant oil, fuels, petrols. So we can say simply gasoline. So that is especially used in these preparations. So what is mainly the solid feedstock is a coal, solid one. So liquid mean biomass, methane, biomass methane, and natural gas. We can use the natural gas also. So especially in the Fischer-Tropsch plant, the feedstock is mainly, we have to use the methane is as a feedstock, which convert into the carbon monoxide and hydrogen. Especially in this process, we have to use the what? Methane as a feedstock, wood feedstock. So methane convert into carbon monoxide and hydrogen, especially in our that is. So solid feedstock, that is coal to methane. So methane, in presence of steam, we will get the water gas. So in the Fischer process, I will conclude this one. Fischer-Tropsch process. So what we have to take, that is a solid feedstock like coal, solid feedstock, that is coal, we can say coal, it's converted into methane. The methane, when react with the vapor, means steam, we can say steam. The methane is then converted into a mixture of carbon monoxide and hydrogen mixture. This is also called as what? Water gas. You can say water gas. The water gas is from where? When methane is react with steam. So we can use in this variety of catalyst such as cobalt. We can use catalyst. So cobalt, nickel, iron, many catalysts we can say. Ruthenium, we can use ruthenium. Ruthenium also we can use. So these are catalysts we can use. So which catalyst is used for in this process? In this process, especially in Fischer-Tropsch process, nickel favors the formation of methane. So if we can use the nickel, So the formation of this nickel favors the formation of methane. Nickel catalyst favors nickel favors the formation of methane. Whereas cobalt catalysts are more active when the feedback is natural gas. If natural gas is there, natural gas converted into carbon monoxide, we have to use the cobalt catalyst favors the formation by the natural gas. If iron catalysts are preferred for low quality feedstock, that such as coal or biomass. So we can use the iron biomass. So low quality feedstock. Biomass are low quality feedstocks. So variety of catalyst we can use the conversion of solid to the feedstock to methane, then methane in the presence of steam to form the water gas, that carbon monoxide and hydrogen mixture. Especially this process was developed by whom? Fisher and both Fisher and Tropsch. H. Tropsch and F. Fisher. The process was developed mainly in Germany. This scientist belongs to Germany. In 1923, year 1923, this process was developed by Fisher and Tropsch in Germany in the year 1923. In this process, just we have to use what we are using? The coal to coke, then coke to steam to water gas. This is the process. Okay? Coal to coke, you can say, in coke. Then steam to carbon monoxide. This is the formation of water gas. So the water gas, the plant, the Fisher scientist developed from water gas to hydrocarbon. That is very, very important in our lesson. So what is that? Mainly the water gas. The gas is purified by passing through iron. Why? Iron oxide, ferric oxide. Why? This gas. Just listen, this one. So what gas we have used? The carbon monoxide, a mixture of hydrogen. Okay. This is the gas. Coming to this one. Here we have to use the what? Fe2O3. So why you are using this one Fe2O3? Because to remove the hydrogen sulfide H2S. Remove H2S sulfide gas. If H2S is present in the mixture, if we can remove by using of what? Ferric oxide Fe2O3. Then the mixture. So then coming from here, we can use another one. It is a mixture of Fe2O3 plus a mixture of everything and base, that is sodium carbonate. We have to use the Na2CO3. So why you are using both this one? First of all, we have removed what? Hydrogen sulfide by using the ferric oxide. Then the gas flow slowly into the another chamber that containing the Fe2O3 and sodium carbonate. Here what we have removed? The remove organic sulfur compound. Here organic sulfur compounds. So in the second chamber, we have removed the what compound? Organic sulfur compound. H2S is the inorganic, iron oxide, iron sulfide, inorganic. Mean that organic mean thioester acid, thiocarbonyl, thiophene. So that type of compound. Thiophene structure, you know, this one is the thiophene. This type of organic compound can be removed by the sodium carbonate and iron oxide, a mixture of ferric oxide and sodium carbonate. So this is the purification technique, okay? The purified gas is compressed. After the purification, this we can use the compression takes place. This is the compressed chamber. Compressed chamber. Gas will come to into the gas coming into the what? Compressed chamber. Here we have to maintain the atmosphere, I mean 5 to 25 atmosphere. We have to take the 5 to 25 atmospheric pressure we have to use. So then from here to after compression we have to allow into the another chamber, that is the catalytic chamber. This chamber is very, very important chamber. Here, catalytic chamber. This catalytic chamber. Now enter into the after the compressed gas. Then let through a converter. We can say converter. This one is the converter. Converter. This converter containing what? Catalyst. We can say. What type of catalyst is there? A mixture of 100 parts of cobalt. Cobalt is how many? 100 parts of cobalt. 100 parts of cobalt. 100 parts of cobalt. 100 parts of cobalt. And 5 parts of thorium. 5 parts of thorium. And 8 parts of Kiesel liquor. This one we have to take in a converter chamber or catalytic chamber. These are a catalyst. So here very, very important, this catalyst. And temperature you have to maintain the 200 to 300 degree temperature. You have to maintain the temperature also. How much? 200 to 300 degree centigrade temperature. So temperature also very, very important in the catalytic chamber. So now a mixture of saturated and unsaturated hydrocarbons reels. From here we can get the, so what? Hydrocarbons. A mixture of hydrocarbon liquid. From here to we can say refining. Then fractional distillation. We can get the gasoline. So this is the big process. So first of all, a mixture of, just listen once again, first of all, a mixture of carbon monoxide and hydrogen along with the other impurities we have to allow into the ferric oxide chamber, so that because here the hydrogen sulfide is removed by the Fe2O3, then allowed into the another chamber using here iron oxide and sodium carbonate to remove organic sulfur. Then allow into the compressed chamber, you have to maintain the atmospheric pressure, that is how much? 5 to 25 atmospheric pressure. Then allow into the converter chamber. The converter chamber containing the 100 parts of cobalt and 5 parts of thorium and 8 parts of kyselium, a mixture of catalyst, and temperature also you have to maintain the 200 to 300 degrees centigrade temperature. Here this results a mixture of hydrocarbons, saturated and unsaturated. I will write the reaction. Saturated and unsaturated liquids will come. From these liquids you can use the refining, then fractional distillation. Already refining of petrol we have seen in the one of the video. You have to listen that video. Refining of petroleum and fractional distillation of petroleum. Then we will get the various temperature, various compounds we will get. Lubricants, paraffin oil, crude oil, petrol, gasoline. So variety of compounds we will get. So this is about the synthetic route. So this was developed by whom? Fisher and Tropsch. Okay. So what are the hydrocarbons? Here a mixture of hydrocarbons. Please draw it. A mixture of hydrocarbons, saturated and unsaturated. First of all, what we have taken in the starting? N number of carbon monoxide and hydrogen. N number we don't know. N number. So, for example, N number of carbon monoxide to N number of hydrogen. N number of carbon monoxide and 2N number of hydrogen. It gives the what compound? So here CnH2n hydrocarbon plus water. N number of water we get water. So what is the formula? This CnH2n. And then N number of carbon monoxide plus 2n plus 1 number of hydrogen. 2n plus hydrogen we have to take. So we will get the CnH2n plus 2. Saturated and unsaturated both compounds we will get here also NH2. So these compounds results from catalytic chamber, catalytic chamber or converter, from converter. So from here this mixture of hydrocarbons, saturated compounds and unsaturated compounds. From these reactions, the reaction mixture. From this reaction, we can refining this crude oil liquid, refining and fractional distillation. These are the hydrocarbon fractional distillation. So the reaction, this reaction is exothermic, especially exothermic reactions. So exothermic means also lot of temperature. From liquid, lot of temperature is released. Immediately we have to this gas so sending into the coolers because high temperature is there. Exothermic means lot of temperature. So out coming very hot gases mixture. So we have to cool it. So cooling gases. So where liquid cool means the gases when in a cooling chamber these gases, hydrocarbon gases get into liquid takes place. So then this liquefied gas is called as what? Crude oil. We can say crude oil. So directly coming from the crude oil where? Oil wells. But synthetically also will get the, after cooling the hydrocarbon saturated and unsaturated compound, we will get that is also same crude oil. Then crude oil in latter process we know that is refining of petroleum and fractional distillation of petroleum. We have to do everything same. But the crude oil synthetically we have prepared. So this process. So it was developed by whom? Tropsch and Fisher in German. in what is the year? In 1923. 1923. Because synthetically also we can prepare by naturally available biomass or natural gas or coal or coke. So but economically this was a little bit more price. So naturally occurring oil well, that is very cheap quality. So that is the reason we are not preparing synthetically a lot. So lot of crude oil imported from Arab countries, especially Kuwait, Iraq. So we are not. So the process we know, but synthetically process that cost is very high. Okay. Though this is the what synthetic petrol. Okay. Thank you very much. So tomorrow we will discuss the another topic, that is the knocking. Okay. Thank you. Bye.